again, it's a positive term series. Just if you want to think about it, I mean, the big problem is the cosine. The cosine bounces back for between plus or minus 1. So, if you start at 1, you get 1 minus, well, the cosine of 1, right, if you think about it, is certainly going to be, the top number is going to be positive then. I got that part covered. And there on out it's going to be positive. So positive term series. And what I would do is, look for a comparison in this one over here. And kind of looking at it, I'm going to look at the n squared minus cosine of n over n4. And for comparison purposes, I'd probably say looking at it, I realize the cosine kind of bounces around a lot. But I'd say a good comparison here would be n squared over n4. And what's that going to be? It would be 1 over n squared, right? So I'm going to say, for comparison purposes, by the way, I'm not doing an inequality in that one. I'm going to say n equals 1 to infinity, that this compares nicely to this one over here. And what about this over here? It's a convergent p-series. All right, what are you going to do? Limit comparison test. Let's write it down. Limit as n goes to infinity. Well, I'm getting a little better at this, so I'm going to write this down. N squared minus cosine n over n4. And we're dividing by this, which is like multiplying by n squared over 1. Let's keep going. That's limit. N goes to infinity. Well, what do you get there? You get n squared on the bottom, and then you get n squared minus cosine n. I still got to do that limit. And what do you get over there? Limit n goes to infinity. Well, n squared divided by n squared is 1. Sorry about that. And then you get minus cosine n over n squared. What's that limit going to give me? Well, the limit of the first term is 1. The second term, I hope you realize the bottom blows up without bound. So this is going to be a limit of 1. So by the limit comparison test, we're going to conclude that this one also converges. All right, that stuff is written up for you. Thank you.